Okay, section 6.1 is law of sines. So up until now we've been dealing with right triangles, but what happens if it's not a right triangle? It's not always going to be. So here I have just a generic looking triangle. There's not supposed to be anything special about it. We need to label the corners and label the sides, and there's a very special way we do that. And we're not going to draw the pictures for you, so you need to understand what the labels mean. So capital letters for the corners. Theoretically, it doesn't matter which ones you label for your capital corners. Understand that this picture is never going to be to scale, because if I had a bigger angle, obviously from my picture I want it to be angle B, but I'm not going to worry about that as long as I do the next step correctly. So capital letters for the angles for the corners. Lowercase letters, the same letter of the alphabet needs to go opposite of the same letter of the alphabet. So if capital A is in this corner, I need to put lowercase a on that side. But that arrow's going to get in my way later. So if capital B is up top, lowercase b, side B, is down below. Capital C, lowercase c. Extremely important that you understand that and do that every single time. Okay, well, we've only dealt with right triangles. So let's see what happens if I make this a right triangle. If I connect straight down, it's supposed to hit at 90 degrees. That would be the height of my triangle. So there's a couple ways to find the height, right? If I use angle A, from angle A, the height is the opposite, and I've cut side B. I can't use side B because H kind of splits it, so I'd have to use C. So from A, I have opposite and hypotenuse. So I know sine of A, of capital A, is going to equal H over C. Well, I could also do that from angle C if I wanted to. Sine of angle C is going to equal H over A. So if I solve both of these for H, multiply by C, and this cross multiply, I guess, is how you can think about it. H is going to be C sine A. Over here, multiply, cross multiply. H is going to equal A sine C. Since those are both equal to H, I can set those equal to each other. C sine A must equal A sine C. And it's just a little more helpful if we divide by the sides. So if I divide both sides by C, and then I also divide both sides by A, I end up getting sine of capital A over little a is going to equal sine of capital C over little c. And if I drew it another way and took the time to show you, that's also going to equal sine of capital B over lowercase b. So this is the law of sines. That is a formula on the page of notes you're probably looking at right now, but this is where it comes from. We're also going to want to find the area of this triangle, these non-right triangles. So if you look at what I have drawn, area of a triangle is always base times height, but base and height are supposed to cross at 90 degrees. So theoretically, the area of this triangle is equal to 1/2 b times h. But we don't know h, and we're not going to take the time to find h, because if you look at our equation down below, never are we going to look for h. Everything we need to know is going to come from capital ABC and lowercase abc. So if I replace h with one of the h's we found earlier, let's go with this one, then now I know the area of this triangle is 1/2 b times, now I'm replacing h, right? So C sine A, and without the weird parentheses, that's 1/2 BC sine A. But you might be saying, well, why did you choose that h? Because you had a whole nother h formula down there. So I also could have replaced it with our other h equation. So also area is equal to 1/2 b, and now I'm replacing h with a sine c. And if I move things around and get rid of the weird parentheses, we like our variables in alphabetical order, right? So that's a, b, sine, c. That's another way I could find the area of the same triangle. And what I want you to notice is that it always contains all three letters, right? BC, lowercase, capital A. AB, lowercase, capital C. There is a third one, and I'm sure you're looking at it on your page right now. Area equals 1/2 BC sine, nope, that one's already there. AC sine B is also on your paper. So these formulas, I tried to show you where they come from for those of you who are interested, but from now on we're just going to believe them and we're going to start using them. So here are my formulas that I just tried to show you why they work. The area ones are actually down here. Oh, I also wanted to mention for the area one, maybe I'll go back over here. I told you it was all three letters. So if it's lowercase b, lowercase c, then it has to be capital A. Also, if you look at that, lowercase b, lowercase c, capital A, it's side angle side, right? Side, the angle in between, and the other side. So your formula is always area equals 1/2 side. Well, I don't want to say it that way. What's my last option? AC sine the other capital letter must be B. So if you have side angle side, you can always find the area. Okay. So if you're given two sides and one angle, there's a lot of possible things that you might have. You might have, I'm just going to make these numbers up. Well, I don't even need to use numbers, right? You might have that. You might have side angle side. Well, if you try to set up a law of sines equation, these law of sines, you need to have a full ratio. So sine A over A, you need to have both the angle and the opposite corner. Or you need to have another ratio, sine B over B, the angle and the opposite corner. Or you would never use three of them. We just like to show you that all three work, right? Sine C and the opposite corner. Well, if I try to partner up A with its opposite corner, it doesn't have one. If I try to partner up lowercase b with its opposite angle, it doesn't have one. Lowercase c, okay, you get it? It doesn't have a full ratio, so that does not work for law of sines. We'll use something else in that situation. If you have side-side angle, so C, B, and then that would be angle B, or theoretically it could be another way, right? You have a full ratio, so B over B, so it is going to work. Either one triangle exists, two triangles exist, or none of them exist. So I will show you an example like that so that you know when one triangle exists, no triangles exist, or two triangles exist. But just know side-side angle, kind of a lot going on. Otherwise, angle side angle, angle angle side, you'll either have one triangle or it won't work at all. So the ones we really want to be careful of is the side-side angle. Okay, let's do an example. So notice the way the question is written. This will be more often than not the way we ask the questions. No picture. You have to draw the picture yourself, and if you draw it wrong, as in you put the numbers in the wrong spots, your answer is going to be wrong. So you're really quickly going to notice my triangles always look the same, and I always label them the same. Capital A, and I'm going to go around B, C. You can put your capital letters wherever you want, but make sure your lowercase letters are opposite of those. So let's fill in what we're given so far. Capital A is 43. Capital B is 76. Lowercase a is 19. So lowercase a is across from capital A, 19. The other sides are the lowercase letters across from the capital letters. So based on the numbers here, we have angle, angle, side. So angle, angle, side, either there's going to be one triangle or no triangle at all. So we're going to do the math to find out. Law of sines. I try to partner up an angle and its opposite side. It does work, so I can use law of sines. Sine of 43 over its opposite side has to equal. Okay, right now I only have one other angle to use, so I am going to use that angle, but I want you guys to realize anytime you have two angles, triangle sum will give you the third angle. But for now, let's use B because it's already written in my picture. Sine of angle B over its opposite side. Okay, we cross multiply. So B sine 43. Never get in between and put anything after the angle, right? B times sine 43. Same thing over here. The 19 goes in front. Sine 76. Those are equal when you cross multiply. If I want to get b alone, I need to divide by sine 43. Divide by sine 43. That would be the exact answer. 19 sine 76 over sine 43. But more often than not, we're going to want the approximate answer. So on your graphing calculator, in degree mode, you're going to type this in. But when you press the sign button, you really need to notice that your calculator starts a parentheses. So after you type in the 76, you must close the parentheses. And then you can press divided by sine 43. When you do that, if you're in the right mode, you should get approximately 27.032. I will always you will always round to 3 decimal places. And then that's an approximation. And I'm not done with this problem yet. It says find all the missing parts. And if I start rounding and then I use that number later and then I round that answer and then I use that number later, I'm going to get further and further away from the actual answer. So at this point, you need to store this number in your calculator. So 27.032 blah, 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 blah should be the last thing on your calculator screen. Hopefully you haven't done anything else since then. And then you're going to press the store button, STO with a little arrow. And then you're going to press the alpha button, which is the green button, top left under the second button. And then I just like to store them alphabetically. So I'm going to press, if you see the math button, how right above it there's a little green A, that's going to have me store my answer in A. So your screen should say answer, arrow, A, and then you need to press enter. So now that whole exact answer is stored in your calculator. And if right now you pressed alpha A and pressed enter, so alpha second math, did I forget to tell you guys to press second when you press math? So alpha second math is how you get that A symbol. So right now, if you just pressed alpha A and pressed enter, it should tell you the 27.032 blah, 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 blah answer that we got before. So that entire thing is stored in your calculator. I need to erase all this, so pause the video if you need to write this down. Now, I need to finish finding everything, right? So over here, I'm going to set up some answer columns, answer blanks. We just found lowercase b as 27.032. We need lowercase c, and we also need capital C, angle C. Always put an angle sign in front of your capitals. Well, I just mentioned angle C. I know a triangle is 180 degrees, and I have 43 plus 76 plus whatever angle C is. So just a little subtraction gives me angle C is equal to 61 degrees. Now I can do law of sines to figure out lowercase c. So I'm doing c's now, right? So sine of 61 over lowercase c. When you set it up, always use the ones that were typed on the paper. So here's the thing. If I got b wrong, if b is not 27 blah, 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 and you start using that in your new equation, now you're going to get your second or third part wrong as well, right? So I'm going to use the green fraction again, the a's, sine of 43 over 19, because those were given in the problem. I know those can't be wrong. Cross multiply. C sine 43 is going to equal 19 sine 61. Divide to get c alone. Type it into the calculator and get your approximate answer. 24.366 if I round to the third decimal. But I might need that later, so see if you can store it in alpha B. So second apps, right? The alphabet, you see the little green letters on top of all the buttons going from left to right? So store that in alpha B in case I need that later. I found C, 24.366. Oh, we also need the area. So remember, the area was the 1/2 AB sine C, or 1/2 BC sine A, or 1/2 AC sine B, right? Use every single letter. So check and see if there's any way you can use only numbers given on the test, right? So side, angle, side. So from our picture, we do not have side, angle, side. So you can choose what you want to do. I'm going to do 1/2. Or let's just do A, B, C, right? So lowercase a was given, 19. Lowercase b, we stored that over here. This is why we stored it. So in my work, I'm going to show the A with a little button around it. And then so I'm at AB sine of C, which is 61. So again, I did 1/2 AB sine C. I just filled it in with the right numbers. So this is why you store things in your calculator. So you are going to type in 1/2 times 19 times. You're going to press second, and then you're going to press the math button because that's where A is. And then times sine 61. And it'll give you the most accurate answer because it stored angle A for you. Sorry, lowercase b in capital A. You should get 224.604. Units squared technically, but I'm not going to take off points for that. Okay, we need to move on. Okay, we need to talk about this side-side angle situation. So I just made one up. I'm going to try to show you why there could be two triangles that exist, but it is very hard to show visually, especially just in 2 dimensions on a video. But here we go. So, based on the numbers we are given, this could be one of the pictures. The other thing that could happen, I'm going to try to make this red. So I've got this side that's 9, and I swung it wide. At corner B, I swung wide, and I made it go down to angle C, right? But what if that same line could swing narrow and connect, oh, it's going to be rude, huh? Connect there. It's not a very good picture. It's not to scale, right? But if that was also 9, and it met the bottom here, then this would be C2, and now I would need to call that C1. So, understand that my triangle could have been the big purple triangle, or it's still possible that the triangle they were describing, A, B, I'm going to call it C2, this could have been 60, this could have been 10, and that could have been 9, and it could have built my red triangle instead. Well, what happens is the 9 matches on both sides, right? This side has a tick mark, this side's a tick mark. I said it's not drawn very great, but that's supposed to be a little isosceles triangle in there, right? So if this angle, I'm just going to make up a number. Let's say that was 50 degrees. Well, then over here, this angle would have to be 50 degrees also, right? This, I'm going to make it green now. This is an isosceles, supposed to be an isosceles triangle. So the 2 base angles are supposed to match. So if I was trying to find the angle here inside the red triangle, angle C2 is going to equal, those make a straight line, right? They're supplementary. So 180 minus 50. Or angle C2 is going to equal 180 minus angle C1. So that will be how we always find the little corner. So that's this corner. I guess I'll label it if you think that's helpful. 180 minus C1 will always give me that corner. And then I can do law of sines from there. So it's hard to visualize. I do not suggest you ever try to draw this yourself. In fact, I will try to never draw it in front of you again because I don't think seeing it is that helpful. But I understand how you might want to see it once. So, example 2. See if you can set up the picture. Again, my pictures will always look the same. Generic non-right triangle, corners going from bottom left, counter or clockwise, and then lowercase. So not drawn to scale, right? Because this is clearly not 117, but it's fine. B is 93, and little b is 67. So in this case, we have angle, angle, side. So from the front, angle, angle, side, either one triangle exists or no triangles exist. So why don't you set up a law of sine equation and see what happens. Did anyone notice anything before they set up a law of sines equation? If we always find the missing angle first, triangles are supposed to equal 180. So 117 plus 93 plus C has to equal 180. Anyone see what's happening here? This is too big. You can't have the angles add to be more than 180. So this triangle is not going to work. If you tried doing this and you cross multiplied and you solved for lowercase a, your calculator would say does not exist or error or something along those lines. So let's move on. By the way, I'm not going to give you one that doesn't exist on test day. Number 3, here we go. Draw your triangle. Label your sides. So I clearly have a ratio. By the way, you can look at it and see. If you have 2 of the same letter, you know you can do law of sines. If you don't have 2 of the same letter, you cannot do law of sines. But this is side-side angle. So potentially we could end up with 2 triangles in this example. So what I want you to do is I want you to try to stay on the left side of your paper. I'm going to try to stay on the left side of my screen to do the first triangle. Notice your answer blanks, C1, B1, etc. for the first triangle. And then if it turns out there is a second one, I'm going to do that on the second side of my screen, right-hand side of my screen. So we've got a matching ratio. So sine of 55 over its opposite side, 9, has to equal sine of C over its opposite side, 10. Cross multiply. This time we're solving for an angle, so you need to divide by the 9 to isolate sine C. To undo sine, you need to do inverse sine. So angle C, and this is technically C1, is going to equal, you're going to do second sine, which will give you the sine inverse, of 10 sine 55 over 9. Remember, your calculator will start a parenthesis for the inverse sine, but it'll also start a parenthesis at 55. You must close that parenthesis before you press divided by 9. If you type this carefully into a scientific calculator in degree mode, you will get approximately 65.529. Let's put it in our answer blank, capital 65.529. Also, we have a lot more to do here. You must store that in your calculator. Store alpha second math. Store alpha second math, yes. Sorry, it's not second. Store alpha gives you the green buttons, and then you press math. So hopefully we've gone over this in class enough that you know how to store that. Store that in A so we have that later. I do not try to match up where I'm storing it with the letter of the variable itself. If you would like, you could start filling in your picture. I don't always recommend it, but so we found angle C. So this is 65-ish. So what could we find next? Well, we could find angle B next. Angle B1. If you know 2 of the angles, it's going to equal 180 minus those 2, minus the 55, and minus button A. Do not round your 65. Use button A. Angle B1 should equal, so 180 minus 55 minus alpha math. We'll subtract that A value for you, and you should get, and round to 3 decimals, 59.471, and store that in button B. 59.471. Okay, we only have left lowercase b. So now we have no choice. We need to use angle B, right? So we're back to our sine of 55 over 9. The A's has to equal sine. I happen to store angle B in button B. That's a coincidence. Pay attention to where you store things. Over lowercase b. So cross multiply. B sine 59 is going to equal 9 sine. Remember, this B is standing for a number. So divide by sine 59. See if you can get the correct answer out of your calculator. 9.464. Area. We're going to finish the first triangle, right? Area. Whenever possible, we want to use side angle side. Since we have the 10 and the 9, we might as well use angle B, right? Side angle side. So 1/2 9 times 10 times sine. What did we save angle B as? Coincidentally, we saved it in button B. See if you can get the correct area answer. You should get 38.762 units squared, but we don't care. Okay. Hopefully you practice these enough that this isn't too bad. That is supposed to be the easier triangle. Now we need to potentially find the other triangle. So I'm going to split my paper. And the reason I do that is that all my math relates to the math on the other side. So we found angle C1. Remember over here? Where is it? Here. I told you angle C2 is always 180 minus angle C1 because whatever this is also here and they make a straight line. So the first step on the second side of your paper is to do angle C2 equals 180 minus, I'm going to write it here, angle C1, but we have that stored as button A, right? You got to keep track of that stuff. So 180 minus button A is going to give us C2. You should get 114, this is approximate, 0.471, and you need to store that, and we are currently on button C if you're keeping up with me. 114.471. Now, I know angle C, right? On the left side, what did you do once you knew angle C? Well, you did triangle sum. So on the right side, we're going to do the same thing. Angle B2 is going to equal 180 minus the 55 because that's still angle A. But now our new angle C is the button C, 114, right? So minus button C. If you do that correctly, angle B2 should come out approximately to 10.529. Store that in button D. Once you knew angle B on the left side, what did you do? Well, you did a law of sines to find lowercase b. So we have sine, it's still sine 55 over 9. That it is not changing. But it's going to equal, we want to use B2. Well, we just stored that in button D over lowercase b. Cross multiply. Oh, I wrote a 55. Oh, did I write a 59 on the other side? Sorry about that, you guys. I did use 55 over here when I typed it into my calculator. I don't know why I had written a 59. A is 55. That does not change. Okay, so on this side, A is still 55. Okay. 5 equals 9 times sine D. Remember, sine D represents a number, so divide by sine 55. And if you type it in carefully, side B2 should be 2.008. And then area for your second triangle. 1/2. I can still use 9 times 10. And then remember we did sine of angle B. Angle B for us is in button D this time. And see if you can get your area approximately. There we go. We are going to do another one, but I told you I would tell you how you know if it doesn't work, right? So you will always do the purple side. That is solving for a triangle. So assuming that all the angles make sense, unlike example 2, you will always do all of the purple side. And you will always start the green side. But if you do this step, triangle sum, and you get a negative answer, can angle B be negative? No, the third angle of a triangle cannot be negative. So if you get a negative here, the second triangle does not exist. Okay. Here we go. Set up your picture and see if you can solve for the first thing we're going to find as well. Okay, based on our picture, we have one complete ratio, the A's, and the only thing I have is a side 15, so you have to use sine of B over 15. Cross multiply. Start getting sine B alone, so divide by 12. To get B out of sine, you do inverse. Remember, we're finding B1. You're going to do second sine to get inverse sine of 15 sine 43 over 12. If we do that carefully, angle B1 should come out to be 58.484, and we're going to need to store this back in A because we're done with problem 3. Once you know angle B, what do? Once you know both angles, right, because technically I know 2 angles in my triangle, then I do triangle sum. C1 is going to equal 180 minus the 43 from the picture, and minus angle B1, which is in button A. So angle C1 is going to equal 78.516. Store that in button B. Once I know angle C, I can set up a sine ratio to find lowercase a. So back to sine of 43 over 12 equals sine of angle C, which is actually button B. It gets confusing. You need to write it down so you can keep track of this, over lowercase c. See if you can solve for lowercase c. And then the area. Side angle side. I like to use the two sides that are given. So 1/2, 12 times 15 times sine of angle C, which is technically button B. But it would work for any side angle side partnership. Okay, this was side angle, so we need to set up the right hand side of our paper. That's fine. And then we need to start by finding, it's not always C, you guys. So what was the first angle we found on the left side of our work? The first angle we found was B1, so you need to find B2. So I need you to know it's not always C. You have to be able to like swap these out or rotate them or however you want to think about it in your head. So B2 is going to equal 180 minus B1. Remember, that was button A. So B2 is going to equal 121.516. Now I'm going to follow my steps. Once I knew angle B on the left, I did triangle sum. C2 is going to equal 180 minus 43, because that's not changing. Oops, did we save this? Save this in button C. Go back and type it in again if you need to, and then store it in C. So minus button C. Angle C2 ends up equaling 15.484. Remember, if that was negative, we would say no second triangle exists, and then you would put does not exist on all these green answer blanks. But because that's positive, it works, and I'm in button D to store it. Then we did our sine. Sine 43 over 12, that's not changing, is going to equal sine of angle C, which is in button D, divided by lowercase c. technically this is C2, you should get 4.698. See if you can find the area. Okay, so obviously we're going to practice this. Make sure you do the practice worksheets and make sure you understand that second triangle part. We have one more example. Read this example to yourself. First thing you need to practice is drawing the picture. So you are standing, so I imagine you're standing on the ground, right? 40 meters from the base of a tree, so this is 40. The tree is leaning 8 degrees from vertical away from you. So this trees are straight, right? But it's leaning away from you. 8 degrees from vertical. So vertical, obviously, is here. My picture's not to scale. 8 degrees from vertical, that's 8 degrees. The angle of elevation from your feet to the top of the tree is 20. From your feet to the top, I guess I'll make it a solid line. From your feet to the top of the tree, the angle of elevation from the ground up is 20. Draw a triangle that represents the problem, show the known quantities on the triangle, and use a variable to represent the height of the tree. X. Write an equation involving the unknown length or height, however you want to phrase it, of the tree. And then find, again, let's just stick with length. That sounds fine. Okay, so we have the 40, but we don't know its opposite angle. We have this 20, but we don't know its opposite side. So what can we do to start filling things in? What about that 8 degrees? Remember, that's not part of my triangle, right? The triangle is all the way from here to here. So the 8 plus this is 90, right? To vertical is 90. This whole thing is 98. Well, if that's 98, can you find the other angle in our triangle? So triangle sum, 180 minus 98 minus 20. That other angle is going to be 62 degrees. Now I have a partnership, 40 and the 62. And then we're trying to find 20 across from the x. So sine of 40, how about sine of the angle, 62, over 40, has to equal sine of our angle, sine of 20, over what we're looking for, x. Cross multiply and see if you can find x. I'm just going to put the answer up. Cross multiply and round to 3 decimals, you should get 15.494 meters. Okay, hope this was a good introduction to sine, and I hope you guys are doing well.